for the button, we are using the black button as a switch only. So the red wire for the black button is connected to the GPIO 6 pin, and the black wire is connected to the ground pin in the Raspberry Pi. These are two inputs which are the proximity sensors that we are using in this material handling system. These two proximity sensors connected in the same way, where they have three wires. The brown wire is connected to the 24 volt supply, and the blue wire is connected to the negative supply of the power. Black wire is connected to the GPIO pin. Here we are using a voltage divider breadboard to divide the voltage so that the Raspberry Pi can detect the changes of input for the sensor. Now look at the picture above. You can see that the blue wire is connected to the smaller resistor and then connected to the ground, which is the 2.2k ohm resistor, whereas the other black wire to the GPIO is connected to the 10 kilo ohm, which is the bigger resistor, so that there is a smaller input for the Raspberry Pi to be detected. For the solenoid, we are connecting one of the two wires to the 24 volt power supply and another wire to the interfacing circuit, which consists of power transistor, resistor and a diode, before going to the GPIO pin. Then from the interfacing circuit, one wire is connected to the ground. 4 of the solenoid is connected the same way, and GPIO pin 18, GPIO pin 21, GPIO pin 24 and GPIO pin 25 is used for the 4 valve solenoid. The connection of the two relay A and B is the same as the connection for the solenoid. Two wires, where one is connected to the power supply and one is connected to the interface circuit, which consists of the transistor, and to the GPIO. For the relay A and B, GPIO 4 and 22 is used. This is a interfacing circuit we are using in this project. The interfacing circuit serves as a circuit between the output and input devices to the Raspberry Pi. The output and input devices are wired to this circuit before wiring to the GPIO pins. For the input device, such as relay or solenoid, they are wired to the left side and the middle bottom side of this circuit as shown in this schematic diagram. Each two pins of this GPIO and solenoid in this circuit indicates for one output devices, where the GPIO pins is wired to the GPIO pins in the Raspberry Pi and the solenoid pins is wired to the output devices. There are a total of 6 pairs of GPIO and solenoid pins, which means there are 6 device output devices that can be connected to this circuit. Then the circuit is connected to the ground pins of Raspberry Pi, and the ground pins is connected to the ground power supply. The input side of this circuit is not used in this project. Instead, we are using the voltage dividing circuit for the sensors. Now will be explaining the coding in Python. The first two lines states to ready the Python to be coded in Raspberry Pi. This line indicates that GPIO is set to BCM mode. Then we set up the pins corresponds to their input and output. Pin 4 is to the relay to run the conveyor. Pin 22 is for the relay to change the direction of the conveyor belt. Pin 26 is set to input for sensor 1. Pin 19 is set for the input for sensor 2. Pin 24 is set to the bottom right valve solenoid. Pin Y, which is pin 25, is set for the top right valve solenoid. Pin 21 is set for bottom left valve solenoid. Pin 18 is set for the top left valve solenoid. And lastly, pin 6 is set for the black switch button. The reason I am using the pull up down, which is the pull up function command here, because I want to utilize the internal register inside the Raspberry Pi to create a high value for the switch first. Next, I'm going to define function for the conveyor, for the valve, and lastly for the main loop. In this conveyor function, there are three status stated in here. The R status means that the conveyor moves in direction 1, where I state a high value in pin 4 and high value in pin 22. When the high value in pin 4 and low value in pin 22, the conveyor runs the other direction. When the pin 4 runs a low value, the conveyor stops. In the left and right valve, they are basically the same, which extends the bottom piston to hold the ball, then retracts quickly and extends the top piston to release the one ball on top of the bottom piston. Then the bottom piston is retracted to release the ball. This sequence is repeated 4 times with a while loop, so that 4 ping pong balls can be released. For the main loop, we are using the if statement. If the black button is pressed where the button is detected as false, the conveyor runs to the right direction. And when the conveyor runs in the right direction, if sensor 1 is detected, which is this pin 26, then the conveyor stops and the left valve sequence is turned on. After the left valve sequence, the conveyor continues to the right. Then, if the sensor 2 detects the box, which is this pin 19, then the conveyor stops and the right valve sequence is turned on. Then, the conveyor turns the direction into left side, and the conveyor will continue to move. And if the black button is pressed again, the conveyor will stop. This is the main program where I set the inertial states of the bottom top piston to make them extend. And the loop is looped inside a while statement. And after this main program, a GPIO cleanup is stated here to clean up the GPIO ports.
material handling system done by Group N5. Basically, the sequence of operation is first we push the black button, which is the power input. Then the conveyor belt will start to move until it reaches the sensor one. The storage box was detected, and then the valve will start to operate. 4 ping pong ball will be dropped into the storage box. Then the conveyor belt now continues to move until it reaches the sensor 2. So now, the storage box was detected by the sensor. The valve will start to operate and 4 ping pong ball will be dropped into the storage box. Then, the conveyor belt will change the direction back to the original place. To stop the conveyor belt, we just need to push the black button again.